Hello and welcome to another Hawkview Collector instruction video. In this video, we'll be looking at the equations module, how to access it, and how to start your own equations based on acquisitions that you have previously started or data that you've collected in Hawkview Collector. But first, I want to remind you that everything that we will be talking about is available in the Hawkview Collector instruction manual, which you can access through the software by clicking on Help. And that should open there it is, the Hawkview Collector Instruction Manual. I've already scrolled it down to the equations section, chapter 20, and this should give you an in-depth guide as to how the equations work and syntax and whatnot that you need to properly set up your own equations. So to access the equation module, you're going to right-click on the equations node in the work tree, click on New, and if this is your first time accessing the equations, it will prompt you to select an equation database, a user function database file. So you can either create a new one or open one. I'm going to create a new one here. We'll put it in our workspace. We'll call it equation database, and that will open the new equation window. This is where you're going to configure your equation, put in everything that it needs to properly run. So let's go over this window. You have your general tag information here, so the acquisition that will be generated and the tag information. And how the equation generator works is that it essentially uses other tags from other acquisitions as inputs, uses your calculation or your equation to calculate an output, and then that is outputted to a tag in an acquisition. So every equation you create will generate an acquisition with one tag. And you need to specify the information on that tag in order for it to properly run. You also have the equation parser, and this is just a text parser that takes a text and then through a series of checks will turn it into an equation that it will use to generate your output. The parser also has a syntax check, so if you just type anything in here, you'll have your errors pop up on the top. So here, error position 1, unknown word or invalid number format. It does not recognize this, but if I put in a number, it recognizes the number. 6 plus 9, that'll give me 15 at every sample point. It's very dull, but it is a functioning equation and it will work. You can also insert a variable, and there are 3 ways to do that. The first is to just type out your variable, and the variable will have a curly brace around it. So you'll have curly bracket, and then your variable, and then closing curly bracket. You can also use the insert variable button here on the side. And the final way is to use Control I, which is your shortcut for insert variable. And you probably noticed that when I typed out my first variable, that was suggested a plus b, and that's because the last 5 equations that you ran will be saved in the dropdown. So here I have 4 equations that I ran, and they're saved in the dropdown menu here. You also have access to the previously mentioned equation database with this open database button, and this will open the database that you opened or created and give you access to everything that's inside it. Now we created a database, so it's empty, but we can modify this by using the add, and we can add a custom function that we will define here. And this is the same equation parser, so let's put in a name for our equation, call it cap top. Let's parse a text, which we'll say is min, and this is a function that is built into Hawkview Collector. There's a list of functions in the user manual that are built in that give you an idea of what they do, how to call them, and what parameters they need. I strongly suggest you read through the list and see if the function you were trying to create is not already there. You may not need to create your own. So we'll call it min, and we'll assign the variable x and use a semicolon to separate the different variables within a method calling. And we'll call it Yes. Now this will give us an equation, and we'll have the equation parameters listed on the side. We can change the order of these parameters. This is the order that they will be called when you call the method, cap top. Let's leave it as x max. Okay, let's save that and close. And now we can call the method cap top. And we can assign variable a, and we can say 50. Now you'll notice that it says variable c is not defined in the prior parameters. We'll get to that in a minute, but essentially that's telling us that we recognize that your equation parsed, you have a variable c is not assigned to anything. So this can't run until you assign a value to c. So let's add test equation, name to this, tag, test q. Suffix description are not mandatory, but let's put min max units. Let's put units. Here we have the sampling frequency, and this is the frequency with which the equation will pull data from the source ax and use it to calculate your output. So while you can sample at a frequency higher than your source ax, it's not recommended if you're using more advanced functions, because you're essentially pulling the same value several times, and if you're trying to do an integration or a differentiation, this may not work. You have on the bottom here your variable configuration. So I can add a variable to my list using the add variable button, and I can add as many as I'd like and remove them at will, and assign the variable here to an acquisition and a tag in that acquisition. The time range preview we'll get into in a minute, but this essentially shows you relative to the other acquisitions that you have selected in this table, where in time this particular acquisition and tag is located. You also have the frequency, so you can use it to match frequencies if you'd like, or to use it as a guide to select your sampling frequency for your equation. The final step before creating an equation is to select a time range. Now, if you do not check your use custom time range, then the entire duration, the entire maximum overlap of your variable selected will be used. If you do select it, then you can modify your time range as you would like. So let's, for instance, let's change this to 48. And now you're seeing that this is showing us our selected time. It's our filter here. Our selected time is telling us that the actual acquisition goes beyond this range preview that you're looking at. You can show all, and the arrow is not there anymore. This is a lot more useful when you have multiple acquisitions. We'll get into that in the next step. But for now, let's create this acquisition over this time range from 4:48 p.m. to 4:50 p.m. So it's asking me if I would like to add the associated tags to the viewer. This is essentially it's asking me if I want to take the source tags and put them in the view as well. And if you're not familiar with the concept of views in Hawkview, I suggest you read up about them in the manual or consult the views instruction video. But now we have our output. And if we compare these, then we can see that this actually started at the start time and end time that we specified, and that the max value here is cap as per our is 50 as per our cap top function that we called. And this is just essentially the output of our equation. So let's look at making perhaps a running equation. So using the live equation feature. We'll reconnect our server, and we'll restart our acquisition here at 10 Hertz. Let's say I want to use the same function. So I can right click on the equation that I just generated in the equations node in the work tree and click on new equation from. And what that's going to do is it's going to populate our equation form with all the same tag information, the same equation, and the same referenced variable as the one that we just called it from. The only thing that's not defined here is the name, which we can assign, we'll just call it test equation live. And then since we're doing this with the live equation, we're going to change to the running acquisition. You can see that our time range preview now has an arrow indicating that this source acquisition is live. Let's not forget to check the live box. If you check this box and you have at least one variable assigned to an acquisition that is not running, you'll get an error saying that you cannot start an acquisition if you do not have, or you cannot start an equation if you do not have live acquisitions. So let's start this. Let's add to the viewer, and let's go to the end and look at our acquisition running. And you can see that the equation is running and it is keeping up with our source acquisition. Let's take a look at, let's restart another one of these and take a look at the time range preview. Now the time range preview, if you use our 2 running acquisitions, it will indicate that we have 2 running acquisitions, and you'll see here that because our selected time is the entire duration, rather, of the all the acquisitions that are running, we see that we have an acquisition that's running its entire duration and one that's relatively new that just started here. If we were to close this and stop the first acquisition and then reopen, we would see that this is now a stopped acquisition, and this live acquisition is moving past it. So we can get a good sense of the relative time of our tags. And we use the filter to view the largest overlap, to view all or our selected time. So if we change our selected time to 45 to 46, well, that's 16, we get a better idea of, we can perhaps zone into the time range that we are interested in. Lastly, I want to look at how you can create an equation from a very, very large acquisition. For instance, if I remove one of these and I go to sample acquisition, we can see that the time range for this, let's just create a very simple A plus B, perfect. We'll call this a large equation. And we'll give it just some values here. Let's leave this at 1 Hertz for now, and let's select these variables. This acquisition is running over the course of a month at a frequency of, well, essentially a period of 1 minute. So if we try and create an equation based off of this, just take 2 tags arbitrarily here and start this, it's going to tell us that, hey, you're oversampling on both of these variables because they're both at frequency of 0.016 and I'm sampling at 1 Hertz. So I do not want to continue. I want to change this to match it and then hit start. I'll add these to the viewer just to get an idea of what's happening, and it looks like it calculated quickly enough. It does not need to emulate a live equation. Well, if you're sampling at a large enough frequency, it may take some time to calculate, and at which point the equation will emulate being a live equation while the calculation is running. And then once it reaches the end of the data, or essentially the predetermined end time of your equation, it'll stop calculation and close down the acquisition. Another time where your acquisition may close down on you is if a calculation error occurs. So if you are, for instance, you have a very complex equation and there's a divided by negative square root, or sorry, divided by 0 or a negative square root involved, you'll have an error appear that says, hey, your equation had to stop because of an error, and the equation will stop generating. And in the equation properties, you will see a warning saying that it stopped due to calculation error. On the topic of the equation properties, let's open one of our equations. And let's go to the properties window. This gives us the properties of the acquisition generated by the equation. On top, we have the tag information of your equation, and underneath we have the information regarding the associated variables and their acquisition. So the variable as well as the acquisition and tag associated to that variable. And that is it for how to generate your own equations, how to start up and view equations in Hawkview Collector. The user instruction manual has a lot of information about the different types of functions that are available and how they can be used. So I do suggest reading up that section before creating your first equations. Hope this video was helpful, and thank you for watching.